Find the intercepts and asymptotes, then sketch the graph of the rational function, state the domain and range. So just like the last video, we need to find four things. Number one is my intercepts, or my zeros. So if I say intercepts, that means x-intercepts and y-intercepts instead of zeros, which is just x-intercepts. Number two, we're going to find the end behavior. Three is going to be the asymptotes. And then four, I need a sign chart. One way to do this all easier is to start off factored form from the very beginning. So in other words, I'm going to factor everything here. So this becomes x plus 1. And if you factor, you know that there's a 2 that comes out. And then the rest of it's going to factor. Now, just trust me for the sake of the video and the time. So it's going to be x plus 2 and x minus 1. All right, now that it's in factor form, everything else actually ends up becoming easier. So I'm going to find my intercepts. So my y-intercept is actually really interesting. As we know, in order to find the y-intercept, we set x equal to 0. So if I set x equal to 0 here, and I'm going to write it down here, we get 2 multiplied by 0 squared plus 2 times 0 minus 4 all over 0 squared plus 0. So this becomes negative 4 over 0. Now this is undefined, which means that there is no y-intercept. And we'll actually see in just a second why there isn't a y-intercept. Now to find my x-intercept. X-intercept is if I set my function equal to 0. Well, if I set the bottom equal to 0, that is where it's undefined. And we'll find, well, this is where the asymptotes are. This is where my zeros are. So if I set the top equal to 0, you'll find that the intercepts are going to be x equals negative 2 and 1. Then I have end behavior. And if you remember, end behavior is going to be the asymptote here. So if I take, so my end behavior is going to be 2x squared divided by x squared, which ends up being 2. So it's going to be a horizontal asymptote at y equals 2. My vertical asymptote is going to be where the bottom is 0, and that's going to be x equals 0 and negative 1. I got that from right here. And now let's do the sign chart. So I'm going to make a sign chart. And what goes on the sign chart are all my zeros and my asymptotes. So we have a intercept at negative 2 and at 1, and then a asymptote at negative 1 and 1 at 0. Now I just plug in points. So I'm going to plug in negative 3, and negative 3 is down this way. So if I plug in a negative 3 plus 2, so I'm looking right here. If I plug in a negative 3 into this x, negative 3 plus 2, that's going to make this negative. Negative 3 minus 1 is going to be negative 4. That's negative. This will be negative, and this will be negative. So a negative times a negative times a negative times a negative. I'm getting that from here, 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 and here. That's going to make it positive here. In between negative 2 and negative 1, so let's say 3 halves, negative 3 halves, or in other words, negative 1.5. If I plug that into here, it's going to become positive. This will stay negative, this will stay negative, this will stay negative. So now I have a positive, negative, negative, negatives. 3 negatives make a negative. So this is going to be negative. In between negative 1 and 0, let's go negative 0.5. Negative 0.5 minus 1 is going to be negative. Negative 0.5, well, that is negative. Negative 0.5 plus 1, that's going to make this positive. So now this is positive. 0.5, that's going to change this one. So that's now going to be negative. And then something big, so like 2. So this is positive now. This is positive, and this is positive. So everything's positive, so this is positive. So let's graph it. In order to be able to see what's really going on, I'm going to make every 3 tick marks 1. So that's -1, that's -2. That's 1, that's 2. So we have x-intercepts at -2, so that's going to be right here, and 1, which is going to be right here. And then I have an asymptote at 0. By the way, this is why we don't have a y-intercept. It's because there's an asymptote there. And then an asymptote at -1. And then I have a horizontal asymptote at y equals 2. So that's going to look right here. So I'm going to start coming from this right here. I need to go down to here. Now, it says it's going to be positive, and then I hit 2, and then I need to go negative, so I'm going to go down negative. Then I hit this asymptote, and I got to stay negative because I know it's not going to become positive again. Then, after -1, it's positive, which means I need to come back up from here. And then I need to go to the next asymptote. And to go from here to here, from -1 to 0, it needs to stay positive. So somewhere in here, it's going to actually turn around and go back up. Now, the next part, after 0, it's going to be negative. So it's going to come down from here. It's going to hit this 0. It's now going to be positive. And then it got to go to y equals 2. So there's my graph. So I have my domain. My domain is going to be from -infinity to -1 with the union of -1 to 0 with the union of 0 to infinity. That's my domain. My range, you're not going to be able to find the range by hand. Mainly because of this point right here. I don't know how high or low that's going to go. But if you had a graphing calculator, which this book expects you to have, you can find the range. So some of these problems you're going to be able to find the range. Other ones you're not going to. It's one reason, actually, why I made this video, to tell you that sometimes you're not going to be able to find the range. But I do know that the range is going to go from -infinity to 2. With the union of, now I'm going to call this line right here, and I don't know what it's going to be, like B. Then I can say it's going to go B to infinity. So once I find what B is, then I can actually find the real range, and that's what you would use a graphing calculator for.